There is a drone sitting in a government archive right now that most people have never heard of. It has no pilot, it has no weapons markings, it carries no Air Force designation, and for a period of time in the late 1990s and early 2000s, it flew over restricted American airspace, conducting test missions that the United States Air Force did not authorize, did not approve, and in some cases, did not even know were happening until after the fact. The agency behind those flights was not the CIA, it was not DARPA, it was not some black-budget Pentagon program buried under layers of classification. It was NASA, the National Aeronautics and Space Administration. The agency that puts telescopes in orbit and sends rovers to Mars was secretly test-flying a stealth drone over American soil and doing it in a way that created one of the most unusual interagency confrontations in modern aerospace history. And the full story of how that happened, why it happened, and what it tells us about the shadow world of advanced aviation research in this country is something almost nobody talks about. If you want to understand what is actually happening in the skies above America and who is really in control of it, stay with me. This story will change the way you think about aerospace, government secrecy, and the fine line between scientific research and military operations. And before we go any further, take 1 second to subscribe. The vast majority of people watching this video right now are not subscribed. It costs you nothing. It takes 2 seconds. And it means you will never miss a story like this one. Now let us start at the beginning. To understand why NASA was flying a stealth drone without telling the Air Force, you first need to understand the environment that made it possible. The 1990s were an extraordinary decade in aerospace. The Cold War had just ended. The Soviet Union had collapsed. And for the first time in nearly half a century, the American military was not facing an existential peer threat. What that created, paradoxically, was not a slowdown in advanced aviation development. It created an explosion of it. Because now, engineers and researchers who had spent decades working under the constraints of Cold War secrecy suddenly had more freedom to experiment. Programs that had been locked in black budgets began generating spin-off technologies. Ideas that had been too expensive or too risky during the tension of superpower competition suddenly seemed worth pursuing. And unmanned aerial vehicles, drones, were at the center of all of it. The military had been using rudimentary drones since the Vietnam era. But by the 1990s, the technology had matured to a point where serious, sophisticated, long-endurance unmanned aircraft were becoming genuinely viable. The Air Force was developing what would become the Predator, and eventually the Global Hawk. DARPA was funding experimental platforms, and NASA, through its Dryden Flight Research Center out at Edwards Air Force Base in California, was running its own parallel program focused on what the agency called environmental research from high altitude. That last part is important. NASA's official mission, the thing that gives the agency its legal standing and its budget authority, is civilian aeronautics and space research, not military operations, not national security, science, atmospheric science, Earth observation, aeronautical technology development, and that distinction, civilian versus military, is what sits at the center of the entire controversy that follows. The aircraft at the heart of this story is the Pathfinder, later evolved into the Centurion and ultimately into the Helios prototype. But to fully understand the controversy, you also need to know about a separate and more secretive vehicle that emerged from that same program lineage. Let us talk about the broader family first, and then we will get to the part that the official history tends to gloss over. The Pathfinder was a remarkable machine. It looked like nothing else flying in American airspace. It was essentially a giant flying wing, a thin, lightweight structure made primarily of carbon fiber and Kevlar, stretching over 100 feet from wingtip to wingtip, covered in solar cells, powered by electric motors, designed to fly at extreme altitudes of 65,000 feet and above, where the air is so thin that conventional aircraft cannot operate for extended periods. It had no cockpit, no pilot, no pressurized fuselage, no jet engine. It was almost entirely silent, and from a distance, at altitude, it was nearly invisible. Not invisible in a radar-absorbent coating sense, but invisible in a practical, operational sense. It flew so high, so quietly, and so slowly that ground-based observers simply could not see it. Radar systems designed to track fast-moving aircraft had difficulty maintaining consistent returns on something that large moving that slowly at that altitude, and its electric propulsion meant no heat signature for infrared detection systems to grab onto. NASA researchers called it a solar-powered atmospheric research platform. They were not wrong, but other people were looking at those same characteristics and seeing something very different. The official story of the Pathfinder program is well documented and genuinely impressive from a scientific standpoint. The aircraft flew its first successful high-altitude mission in 1997, reaching over 71,000 feet. It was the highest an aircraft powered purely by solar energy had ever flown at that time. Subsequent development led to the Centurion, which stretched the wingspan even further, and then to the Helios prototype, which in 2001 set an absolute altitude record for a propeller-driven aircraft at over 96,000 feet. These were real achievements. They proved that persistent, high-altitude, solar-powered unmanned flight was not just a theory, it was possible, and the scientific value was genuine. At those altitudes, an unmanned platform can function as a pseudo-satellite, providing persistent observation of a specific geographic area for weeks or even months at a time, at a fraction of the cost of an actual satellite, and with the flexibility to be repositioned as needed. Agricultural monitoring, forest fire detection, telecommunications relay, hurricane tracking, climate research. These were the applications NASA was publicly discussing. But here is where the story gets complicated, because the same capabilities that make a platform useful for monitoring forest fires also make it extraordinarily useful for military surveillance. Persistent, silent, ultra-high altitude, undetected overflight of a target area. That is not just an environmental research tool. That is a reconnaissance asset, and the United States military knew it. The relationship between NASA Dryden and the Air Force at Edwards Air Force Base was, on its surface, a model of interagency cooperation. They shared a runway, they shared some facilities. They had decades of collaborative history going back to the earliest days of the X-plane program, where Air Force test pilots and NASA researchers worked side by side on experimental aircraft. Chuck Yeager broke the sound barrier in 1947, flying an Air Force aircraft over a program that NASA's predecessor agency, the NACA, was deeply involved in. The culture at Edwards was one of shared purpose, but that culture also meant that the lines between military and civilian research were not always clearly drawn. And when you are operating highly experimental unmanned aircraft over restricted test ranges, those blurry lines can create serious problems. The Federal Aviation Administration has authority over civilian airspace. The Air Force has authority over military airspace. And the protocols for who needs to notify whom before flying what kind of aircraft in which kind of airspace are extremely detailed and extremely important, especially when you are flying something that looks, for all practical purposes, like a stealth surveillance platform. The specific incident that crystallized the tension between NASA and the Air Force did not happen all at once. It was not a single dramatic confrontation. It was a slow accumulation of operational decisions, each one individually defensible, that collectively added up to something that the Air Force found deeply problematic. Here is what we know. During the development and testing of the Pathfinder and its successor vehicles, NASA Dryden conducted multiple test flights, some of which were coordinated through the appropriate channels, and some of which were not. The flights that were not fully coordinated were not rogue operations in any kind of rebellious sense. They were, from NASA's perspective, simply research flights conducted within airspace that NASA had legal authority to use for its programs. The problem was that the Air Force interpreted some of those flights differently, because the aircraft being flown, a large, high-altitude, low-observable, unmanned platform, fell into a category that the Air Force believed required explicit military coordination and approval, regardless of whether the operating agency was civilian or military. The Air Force had protocols, hard-won, carefully developed protocols, for tracking and deconflicting unmanned aircraft in shared airspace, and from their perspective, NASA was operating outside those protocols, not because NASA was being deceptive, but because NASA and the Air Force had fundamentally different views of what kind of vehicle they were dealing with. NASA said, research platform. Air Force said, military-adjacent surveillance asset. And that disagreement had real operational implications. To understand why the Air Force reacted the way it did, you need to understand what was happening in the unmanned aircraft world in the late 1990s from the military's perspective. The Air Force was in the middle of one of the most significant doctrinal shifts in its history. Unmanned systems were moving from the margins of military aviation to the center of it. The Predator had just begun operational missions over Bosnia and would soon be flying combat operations. The Global Hawk was completing its initial development and was about to demonstrate that unmanned aircraft could fly coast to coast across the United States autonomously. The Air Force was investing enormous resources, political capital, and institutional energy into establishing itself as the lead agency for military unmanned aviation. They did not want a civilian agency, even one as respected as NASA, operating large, high-altitude unmanned aircraft that could be confused with, or that could set precedents affecting, military unmanned systems without Air Force oversight. The Air Force was also dealing with a deeper institutional anxiety about unmanned aircraft in general. There was a significant faction within the Air Force, particularly among career pilots, that viewed the rise of unmanned systems with concern. They saw autonomous aircraft as a threat to the pilot-centric culture that had defined the service since its founding. And if NASA was out there demonstrating that large unmanned aircraft could operate effectively in American airspace without military involvement, that complicated the Air Force's efforts to maintain control over the narrative and the policy framework around unmanned aviation. So when news of NASA flights that had not been fully coordinated with Air Force systems began circulating through Air Force channels, the response was not casual. The internal communications that emerged from this period, some of which have been discussed in aerospace policy papers and congressional testimony, paint a picture of genuine institutional friction. Senior Air Force officers were, in the words of people familiar with the situation, seriously irritated. The language used in some internal discussions was considerably stronger than that. The Air Force's position was straightforward. Any unmanned aircraft with the characteristics of NASA's high-altitude platforms, specifically high-altitude, long endurance, and low observability, needed to be coordinated through military channels before flying, period. NASA's position was equally straightforward. These were civilian research aircraft operating under NASA authority for scientific purposes, and the appropriate oversight body was the FAA, not the Air Force. Both positions were legally defensible, and that is precisely what made the situation so difficult to resolve. This was not a case of clear wrongdoing. It was a case of two powerful agencies, each with legitimate authority and legitimate interests, operating from fundamentally different frameworks for understanding what kind of aircraft they were dealing with. The aircraft sat at the intersection of two worlds, civil and military, scientific and strategic, and neither world's existing rules quite fit it. Now here is where the story becomes even more interesting, because the friction between NASA and the Air Force over the high-altitude solar aircraft program was not the only chapter in this story. Running in parallel, and significantly more obscured from public view, was a related program that pushed the boundaries even further. Documents and testimony from people involved in advanced aerospace research during this period indicate that NASA Dryden was not the only NASA center operating experimental unmanned platforms that generated interagency concern. There were elements of the agency's research portfolio that touched directly on what could only be described as reconnaissance and surveillance technology, even if the official framing was always atmospheric research or Earth observation. The architecture of high-altitude persistence is inherently dual use. That is simply a fact. A platform that can fly for weeks at 70,000 feet, looking down at weather patterns, can also, with different sensors, look down at military installations, border crossings, or the movements of people and vehicles on the ground. NASA researchers knew this, Air Force planners knew this, and the intelligence community knew this. What made the situation complicated was that each of these communities had a different view of who should be in charge of developing and operating these platforms. NASA wanted to maintain its civilian identity and its scientific mission framing. The Air Force wanted military control over anything that looked like a surveillance asset. And in between, various elements of the intelligence community were watching with great interest, because persistent high-altitude unmanned surveillance was exactly the kind of capability they had been wanting for decades. The U-2 had provided that kind of capability In the 1950s and 60s, satellites had provided a version of it since. But a solar-powered unmanned platform that could loiter over a specific area for months at a time was something qualitatively different from either, and the question of who owned that capability, who controlled its development, and who had authority over its operations was one that none of the existing institutional frameworks was well equipped to answer. Let us talk about the stealth dimension of this story, more specifically, because this is where things get genuinely fascinating. The word stealth, when most people hear it, conjures images of the B-2 bomber or the F-117 Nighthawk. Dramatic angular shapes, coated in radar-absorbing materials, specifically engineered to defeat radar detection. That is one kind of stealth. But there is another kind, what engineers and operators sometimes call passive stealth or practical low observability. And it does not require any special coatings or exotic materials. It simply requires an aircraft that is, by virtue of its design and operating profile, extremely difficult to detect, track, and identify through conventional means. The Pathfinder and its successors had this kind of practical stealth in abundance. Consider the operating environment. At 65,000 to 96,000 feet, the aircraft was above the ceiling of virtually every conventional military and civilian aircraft in existence. Surface-to-air radar systems designed for tracking fast-moving threats had difficulty acquiring and maintaining a track on a very slow-moving target at extreme altitude. The aircraft's electric propulsion meant it produced no acoustic signature detectable from the ground and no infrared signature from jet exhaust. Its carbon fiber and Kevlar construction gave it a minimal radar cross-section compared to conventional aluminum-skinned aircraft, and its operational altitude meant that from the ground, even with optical instruments, it was effectively invisible to the naked eye. From a practical operational standpoint, this aircraft could fly over virtually any location in the continental United States or anywhere else within its range, and be essentially undetectable by most conventional observation methods. That is stealth, not the exotic, classified kind, the practical, operational kind. And it raised a question that made the Air Force extremely uncomfortable. If NASA could field a large, capable, essentially undetectable, unmanned aircraft for scientific research, what did that say about the ability of other actors, foreign governments, non-state organizations, or even other U.S. agencies, to field similar platforms for less benign purposes? The Air Force had spent decades developing doctrine, systems, and protocols for managing military airspace and detecting potential threats. The emergence of a whole new class of aircraft that sat completely outside those frameworks was not just an administrative inconvenience, it was a doctrinal challenge. The broader context here is the history of the relationship between NASA and the military in the realm of classified and sensitive aviation programs. This relationship goes back to the very founding of NASA in 1958. NASA was established in the immediate aftermath of Sputnik as America's civilian response to the Soviet space challenge. But from the beginning, the boundary between NASA and the military was porous. NASA used military rockets. NASA trained military test pilots. NASA conducted research that had obvious military applications. And in some cases, NASA provided official civilian cover for programs that were, in substance, military or intelligence operations. The most famous example is the U-2, the high-altitude reconnaissance aircraft that Gary Powers was flying when he was shot down over the Soviet Union in 1960, was officially operated by NASA for atmospheric research. That was the cover story. The real operator was the CIA. The real mission was reconnaissance of Soviet military installations. When Powers was shot down and the Soviets produced him as evidence, the cover story collapsed, and it became one of the most significant diplomatic incidents of the Cold War. The point of that history is not that the solar drone program was a CIA operation. The available evidence does not support that conclusion. The point is that the precedent of NASA providing cover or legitimacy for programs with military or intelligence dimensions was not invented in the 1990s. It had a long history, and people inside the Air Force and the intelligence community who were aware of that history had reason to look at the high-altitude unmanned aircraft program through a lens of institutional memory as well as current operational concern. The specific details of which flights were conducted without full Air Force notification, and exactly what information was shared or withheld, with which agencies at which times, remain partially obscured by classification and by the general culture of institutional discretion that surrounds sensitive aerospace programs. But the broad outlines of the situation are clear from publicly available sources, including congressional testimony, Government Accountability Office reports, and statements from people who were involved in or adjacent to the program. What is clear is this: NASA conducted test flights of high-altitude unmanned aircraft that the Air Force believed should have been coordinated through military channels and were not. The Air Force raised formal objections through interagency processes. Those objections led to extended negotiations over protocols, authorities, and responsibilities for high-altitude unmanned aircraft operations. Those negotiations were, by all accounts, contentious and protracted, and they ultimately contributed to the development of new interagency frameworks for managing unmanned aircraft in national airspace, frameworks that acknowledged the dual-use nature of these platforms and attempted to establish clearer lines of authority and coordination. The aftermath of this interagency friction had lasting consequences for the entire unmanned aircraft industry in the United States. One of the most significant was the development of what became known as the UAS Integration Framework, a set of policies and procedures for incorporating unmanned aircraft systems into the national airspace in a way that addressed both safety concerns and the competing jurisdictional interests of different agencies. The FAA, the Air Force, NASA, and eventually the Department of Homeland Security all had stakes in this process. The result was a regulatory and operational framework that was significantly more complex and restrictive than what NASA had been operating under during the early years of the Solar Drone program. Some researchers at NASA Dryden found the new restrictions frustrating. They felt that legitimate scientific research was being slowed and complicated by military and security concerns that, in their view, did not apply to aircraft designed purely for atmospheric research. But others acknowledged that the old framework, which had essentially allowed each agency to apply its own interpretations of airspace authority, was not sustainable once unmanned aircraft became numerous enough and capable enough to pose real deconfliction challenges. The Helios disaster of 2003 added another dimension to this story. On June 26, 2003, the Helios prototype, then the most advanced version of the Solar Wing design, broke apart in flight over the Pacific Ocean near Kauai, Hawaii. The aircraft had encountered atmospheric turbulence that caused an unexpected change in its wing geometry. The extreme flexibility that made the design efficient at solar collection also made it vulnerable to certain loading conditions that the design team had not fully accounted for. The aircraft descended and broke up over the ocean. No one was injured, since the aircraft was unmanned, but the loss was a significant setback for the program, and it had an interesting effect on the interagency dynamics that had been building around the platform. The Air Force's response to the Helios accident was, in the assessment of people familiar with the situation, somewhat complicated. On one level, the loss of a major NASA research aircraft was a genuine scientific setback that everyone in the aerospace community took seriously. On another level, the accident reinforced an argument that some Air Force planners had been making all along, that large, high-altitude unmanned aircraft were operating in a risk environment that required more rigorous military-style safety and operational oversight than the NASA research culture typically applied. NASA had excellent safety processes, but the Air Force had decades of experience managing the operational risks of advanced experimental aircraft in complex airspace environments, and the Helios accident gave credibility to the argument that the two safety cultures needed to be better integrated, not just for the Air Force's jurisdictional reasons, but for actual operational safety. It is important at this point to address what this story is not. It is not a story of deliberate deception or malicious intent on NASA's part. The people at Dryden who developed and flew these aircraft were genuine scientists and engineers doing work they believed was important and legitimate. They were not trying to build military surveillance assets. They were trying to advance the science of solar-powered flight and demonstrate capabilities that had genuine, peaceful applications. The friction with the Air Force arose, not because of bad faith on either side, but because the technology they developed fell into a genuinely ambiguous space between civilian and military domains. And in that ambiguous space, two powerful agencies with different institutional cultures, different legal frameworks, and different operational priorities collided. That kind of collision is not unusual in the history of advanced technology. It happens whenever a new capability emerges that does not fit neatly into existing categories. The atomic bomb created similar institutional conflicts between the Army, the Navy, and eventually the Air Force over who owned nuclear weapons and nuclear strategy. The early space program generated intense conflict between NASA and the military services over who would control human spaceflight and military satellites. Unmanned aviation was simply the next frontier in that long history of technological emergence, creating institutional disruption. But here is what makes this particular story different from those earlier conflicts: the scale of what unmanned aviation has become. In 1997, when the Pathfinder was setting altitude records, unmanned aircraft were a niche technology, a fascinating, rapidly developing technology, but still a niche one. Today, in the era of Predator, Reaper, Global Hawk, and dozens of other military and civilian unmanned systems, the questions that NASA and the Air Force were fighting over in the late 1990s have become some of the most consequential questions in military doctrine, international law, and national security policy. Who controls unmanned aircraft? What rules govern their operation? Where is the line between scientific research and military surveillance? What constitutes an act of war when an unmanned vehicle crosses a national boundary? These questions, which were being worked out in interagency meetings at Dryden and Edwards and the Pentagon in the late 1990s, are now being debated in the United Nations. They are shaping arms control negotiations. They are affecting the calculations of every military power on Earth. The story of NASA's stealth drone and its conflict with the Air Force was not a minor bureaucratic disagreement. It was an early chapter in one of the most significant military and technological revolutions of the modern era. Let us go deeper into the specific technical characteristics of these aircraft and why those characteristics were so alarming to Air Force planners. Because the numbers involved are genuinely extraordinary. The Helios prototype, at the peak of its development, had a wingspan of 247 feet. That is larger than a Boeing 747. It weighed just over 2,000 pounds fully loaded, which for an aircraft of that size is astonishingly light. It was powered by 14 electric motors, driving 14 propellers, all running off solar cells, covering the upper wing surface. It could carry a payload of several hundred pounds of scientific instruments to altitudes above 60,000 feet and sustain flight there for days at a time. Now consider what those specifications mean from an operational surveillance standpoint. An aircraft the size of a jumbo jet, carrying hundreds of pounds of sensors, flying silently and essentially invisibly at 60,000 to 96,000 feet, with the potential endurance of days to weeks. From that altitude, the sensors available in the late 1990s could resolve objects on the ground to remarkable levels of detail. Modern satellite imagery is impressive, but satellites move continuously in their orbits. A given satellite passes over a specific geographic location only periodically. A persistent unmanned platform can stare at the same location continuously, which is operationally far more valuable for many surveillance applications. The combination of size, payload capacity, endurance, altitude, and practical low observability made these aircraft, whatever NASA's stated purpose, exactly the kind of platform that military planners and intelligence professionals had been dreaming about for decades, and they were being developed by a civilian agency that was not subject to the same oversight, classification protocols, or operational controls that military programs operated under. From the Air Force's perspective, that was not just a procedural problem, it was a strategic problem. There is another layer to this story that deserves careful attention: the role of private contractors. The development of the Pathfinder, Centurion, and Helios platforms was not done by NASA engineers alone. The primary contractor for the vehicles was AeroVironment, a California-based aerospace company that specialized in small and unmanned aircraft. AeroVironment had its own research agenda, its own intellectual property portfolio, and its own relationships with other government customers, including the military. The technology being developed for NASA's research program was not locked away in a government laboratory. It was being developed by a private company with multiple customers and interests. This created additional complexity around questions of technology transfer and security. If the solar wing technology had military applications, as the Air Force clearly believed it did, then the development of that technology by a contractor with broad government relationships raised questions about how that technology would be controlled, who would have access to it, and how it would eventually be used. AeroVironment went on to become one of the most significant unmanned aircraft companies in the world. Their Raven small unmanned aircraft became the most widely deployed unmanned system in the U.S. military. Their larger platforms have been used in classified and unclassified programs around the world. The technology lineage that runs from the early solar wing research through AeroVironment's subsequent commercial and military products is a direct one. And it is worth noting that the foundational work on those technologies was done under NASA's civilian research umbrella, at a time when the interagency frameworks for controlling dual-use unmanned technology were still being worked out. What happened to the people at the center of this story is instructive. The engineers and scientists at Dryden, who worked on these programs, did not face any formal discipline or legal consequences for the flights that generated Air Force concerns. That is important. Whatever the Air Force believed about jurisdictional overreach, the NASA researchers were operating within their understanding of their legal authority. The outcome of the interagency conflict was not punishment for individuals, but restructuring of processes, new memorandums of understanding between NASA and the Air Force, new coordination requirements for unmanned aircraft operations in certain airspace categories, new joint review processes for experimental unmanned platforms with characteristics that triggered military interest. These bureaucratic outcomes may sound dry, but they had real consequences. They established precedents that shaped how the entire unmanned aircraft ecosystem would be regulated as it grew from a handful of experimental platforms in the late 1990s to the thousands of vehicles that operate in American airspace today. The rules that govern where and how large unmanned aircraft can fly, who needs to be notified before a flight, what safety systems are required, how airspace conflicts are resolved, all of those rules have their roots in the conflicts and negotiations of the period we are discussing. Every company flying commercial drones today, every military unit operating a surveillance platform, every research institution conducting atmospheric science with an unmanned vehicle is operating within a regulatory environment that was shaped in part by the friction between NASA and the Air Force over a solar-powered wing flying over the Mojave Desert. There is one more dimension of this story that very few people discuss, and it is perhaps the most philosophically interesting. The question of what secrecy even means when the thing being kept secret is visible. One of the stranger aspects of the NASA stealth drone story is that the aircraft themselves were not secret. They were not black programs. They were not hidden in classified hangars. The Pathfinder flew public missions. There were press releases. There were photos. There were media days at Dryden. NASA was proud of what it was building and happy to share the story of solar-powered atmospheric research with the public. But the operational details of specific test flights, the exact nature of some sensor payloads, the specific coordination discussions with other agencies, and the nature of the interagency friction that was developing, those things were handled with considerably more discretion. So you had this unusual situation where a potentially revolutionary dual-use military technology was being developed more or less in public by a civilian agency, while the institutional conflicts it generated were being managed privately, and while its most sensitive operational implications were being discussed in classified settings by people from the military and intelligence communities. The aircraft was not secret. Its significance was. That is a very particular kind of secrecy, and it is one that becomes more common, not less, as technology advances faster than the institutions designed to govern it can adapt. The drone was visible. The argument about what it meant was not. The lessons of this story extend well beyond the specific programs and agencies involved. They speak to a fundamental tension in how advanced democracies manage the development and deployment of dual-use technology. On one side, you have the imperative of scientific openness. Science advances through the free sharing of results, through peer review, through the accumulation of knowledge that any researcher can build on. NASA's culture, at its best, embodies this principle. On the other side, you have the imperative of national security. Advanced capabilities, once demonstrated, can be replicated. Knowledge of a capability's existence and operating parameters gives potential adversaries information they can use to counter it or to develop their own version. The military's culture, at its best, embodies the principle of controlling that kind of information. When a technology sits at the intersection of these two imperatives, as high-altitude unmanned aircraft clearly did in the late 1990s, neither culture's framework is fully adequate. You cannot simply declare it open science, because the implications are too strategically significant. You cannot simply classify it as a military program, because the underlying research was legitimately civilian in its conception and much of its execution. The result is the uncomfortable middle ground that the NASA Solar Drone program occupied, a space where accountability is diffuse, authority is contested, and the rules are being made up in real time by people who are simultaneously trying to do important work and to protect their institutional interests. That is an uncomfortable place to be, but it is where the most important technological developments of any era tend to happen, because the most important technologies are always the ones that do not fit neatly into the categories that already exist. Now let us talk about what came after, because the legacy of the NASA stealth drone controversy is not just historical, it is very much alive in the present day. The unmanned aircraft industry that grew out of the research done in the 1990s and early 2000s, including the solar wing programs at Dryden, has become one of the most significant sectors in both the defense and commercial technology worlds. The military applications are well known. Predator, Reaper, and Global Hawk became central to American military operations in Afghanistan, Iraq, Syria, Libya, and across the broader arc of counterterrorism operations that followed September 11, 2001. These aircraft, and the doctrine of persistent unmanned surveillance and strike that grew up around them, transformed the way the United States projects power in ways that are still being absorbed and debated. But the high-altitude, long-endurance segment of the market, the direct descendant of the NASA Solar Wing research, has continued to develop along lines that mirror the dual-use tensions of the original program. Today, platforms like the Global Observer, the Vulture program, and various classified high-altitude unmanned programs represent the matured version of what NASA was researching in the late 1990s. The scientific potential is real and impressive. Atmospheric research, communications relay, agricultural monitoring, disaster response, climate observation, all of the civilian applications that NASA was developing these platforms for are now being pursued commercially and by civilian agencies. But the military and intelligence applications are equally real and equally impressive, and the question of who controls these platforms, who has authority over their operations, and how their use is governed in international airspace, those questions are still being worked out. They are the same questions that generated the conflict between NASA and the Air Force decades ago. They have simply moved from the test ranges of the Mojave Desert to the conference rooms of the United Nations and the negotiating tables of international arms control discussions. There is something important to say here about the people on the ground at Edwards and Dryden who lived through this history, not the program managers and agency heads who fought the interagency battles in Washington. The actual engineers, pilots, and technicians who built and flew these aircraft. By most accounts, those people were extraordinarily dedicated. They were working on something they believed in. The idea of a solar-powered aircraft that could fly for months at a time, providing continuous observation of the Earth's surface, was genuinely inspiring to the people doing the work. It represented a kind of aerospace achievement that had never been done before. And they were doing it with very limited resources, under significant technical constraints, solving problems that had no established solutions. The solar cells were new technology. The composite materials were being pushed to their limits. The flight control systems for an aircraft with that kind of flexibility and that kind of wingspan were unlike anything that had been developed before. Every flight was a test. Every flight involved risk. And the people who designed, built, and operated these aircraft were aware of that risk and accepted it because they believed the work was worth doing. That is a very particular kind of professional courage. It is not the courage of combat, but it is real, and it deserves to be recognized. Whatever the institutional controversies surrounding the program, The engineers and researchers who built these aircraft were doing genuine pioneering work, and many of them found, over the course of their careers, that the dual-use dilemmas generated by their work were deeply uncomfortable to navigate. They had not signed up to be at the center of military-civilian jurisdictional conflicts. They had signed up to build aircraft. The politics came with the territory. The figure who perhaps most embodies this tension is Jeffrey Bland, who managed NASA's solar aircraft program for a significant portion of its critical period, and who has spoken publicly about both the achievements and the frustrations of the work. Bland and his colleagues genuinely believed in the scientific mission. They genuinely believed that high-altitude solar flight had transformative potential for Earth science, and they navigated the complex interagency environment with what they described as consistent effort to comply with the applicable regulations, even as those regulations evolved and sometimes applied inconsistently to their work. Their perspective, that they were scientists doing science, and that the military's jurisdictional concerns, while understandable, were sometimes disproportionate to the actual risk posed by their civilian research aircraft, is coherent and defensible. But so is the Air Force's perspective, that an aircraft with those characteristics and that kind of operational potential deserved military-level oversight, regardless of who was flying it. The truth is that both perspectives reflect genuine values and genuine concerns, and the conflict between them was not resolved by either side being definitively right or definitively wrong. It was resolved, to the extent it was resolved at all, by institutional negotiation, by the development of new shared frameworks, and ultimately, by the sheer growth of the unmanned aircraft ecosystem, which eventually made the old jurisdictional conflicts obsolete by forcing everyone to develop new rules that applied across the board. What does all of this mean for the future? Because the forces that created the NASA stealth drone controversy have not diminished. They have intensified. The commercial drone industry today operates at a scale that would have been unimaginable in the late 1990s. There are millions of small unmanned aircraft in operation in the United States alone. The FAA has spent years developing a regulatory framework for integrating these aircraft into the national airspace. But the high-altitude, long-endurance segment of the market is still growing, and it is still generating the same kinds of dual-use tensions that characterized the early Solar Wing program. Companies like Google, Facebook, and others have invested billions of dollars in high-altitude unmanned platforms for communications relay and internet access. These platforms operate in the same airspace, at similar altitudes, using similar technologies as the military and intelligence community's most sensitive unmanned reconnaissance platforms. The lines between commercial, scientific, and military in this airspace are, if anything, even blurrier than they were in the era of Pathfinder and Helios. The interagency frameworks that were hammered out in the aftermath of the NASA Air Force conflict of the late 1990s and early 2000s are being stress-tested by this new commercial reality, and in some cases, they are not holding up well. The question of who has authority over high-altitude unmanned operations, who bears responsibility for deconfliction and safety, and how civilian and military operations in shared airspace are managed. These remain live and contested policy questions. They will continue to be live and contested for the foreseeable future, because the technology continues to advance faster than the institutions designed to govern it can adapt. That is not a failure of any particular agency or any particular set of people. It is the fundamental challenge of governing advanced technology in a democratic society. You cannot know in advance exactly where the important tensions will emerge, because you cannot know in advance exactly what the technology will be capable of. By the time you know, you are already inside the controversy. The story of the NASA stealth drone and the Air Force is in many ways a parable for our technological moment. It is a story about what happens when a capability emerges that does not fit neatly into existing categories. When the lines between civilian and military, between science and surveillance, between openness and secrecy cannot be clearly drawn, it is a story about how institutions that were designed for a different technological era struggle to adapt when the technology changes faster than the rules. And it is a story about the people, the engineers, the military planners, the policymakers, the researchers, who have to navigate those ambiguous spaces in real time, making decisions under uncertainty, with incomplete information, in a world that did not give them a clear playbook. Those people, on both sides of the NASA Air Force divide, were doing their jobs as best they could within their institutional frameworks. They disagreed, sometimes intensely, but the disagreement was productive, in the sense that it forced the development of new frameworks that eventually governed one of the most consequential technological developments of our time. The unmanned aircraft revolution has changed warfare, changed surveillance, changed scientific research, changed the commercial technology landscape, and changed the fundamental relationship between states and the airspace above their territory. All of those changes have roots in the period we have been discussing, and the story of the solar drone that NASA flew without telling the Air Force, a story that sounds small and procedural, when stated plainly, turns out to be a window into one of the deepest transformations in modern military and technological history. There is a postscript to this story that is worth knowing. AeroVironment, the company that built the Pathfinder, Centurion, and Helios platforms for NASA, continues to be one of the most significant unmanned aircraft companies in the world. Their Puma, Raven, and Wasp systems are used by military forces around the world. Their Hawk 30 platform, a direct descendant of the solar wing technology developed in partnership with NASA, was being tested by SoftBank for communications relay purposes over Hawaii in the late 2010s, generating its own questions about airspace authority and regulatory oversight that echoed the concerns of 2 decades earlier. The technology does not stand still. The questions it generates do not go away. They recede, and then they return in new form, applied to new platforms, in new regulatory environments, with new stakeholders. But the fundamental tension between the power of a dual-use technology and the institutions trying to govern it persists. It will persist as long as human beings continue to push the boundaries of what is technically possible, which is to say, it will persist forever. And the people who navigate those tensions, the scientists who want to fly, the military planners who want control, the regulators who want safety, the entrepreneurs who want markets, will continue to collide, negotiate, disagree, and eventually reach new accommodations that hold until the next technological development renders them insufficient. That is the story of advanced technology in a democratic society. It is messy, it is contentious, and it is how progress happens. The solar wing that flew silently at the edge of space, over the